Recording here. All right, as I stated before, this is week 14 of 15. Only one more week to go. And I just want to remind you all, everything is due on that Friday, or no, the Sunday, excuse me. Sunday, help me out here. What day is Sunday next week? Sunday, May 3rd. Everything is due on the 3rd. And that includes the final, which I'll talk about briefly after the lecture. All right, so let's get started. This is week 14. The topic is recognizing and managing dependencies. And dependencies are just that. And you see this a lot in the database world because data are changing constantly, but the structure of the database should remain consistent. When the structure changes, then the dependencies are thrown off and procedures. So that's primarily what we're going to talk about. So in PL SQL, some objects reference other objects as a part of their definitions. We got, variables and parameters, and basically that's the overarching definition of dependencies. It's just objects that reference other objects. So in this section, basically we're going to highlight, how do you manage these dependencies? How can you highlight them? How can you view them? For our experience, I'll let you know that generally you can essentially capture dependencies without going through some of the processes because we're using relatively basic PL SQL blocks and procedures, and essentially our knowledge of the table should be at a high level, so we're not running into things like mutating tables, etc. So basically, you're going to learn how to write code. So dependency failures are, well, basically they don't happen. You want to make sure that you're not running into something that's failing your code because of a dependency failure. And finally, basically, I'm going to show you how to view and maintain dependencies if you need to. So if there's any type of issue or the likelihood of failure, you can take a look and view and make the changes accordingly. So that's one of the biggest concerns. So I'm going to go through lesson 1, and the objectives are describe the implications of procedural dependencies, contrast dependent objects, and reference objects, view dependency information in the data dictionary, use the util tree script, and we are going to try and run that, but use that script to create objects that require, basically you're going to display the dependencies, and then the idep tree and the dep tree to view and actually view and display dependencies. Okay, then you're going to describe when automatic recompilation occurs, and list how to minimize the dependency failures. Yeah, that's a mouthful. All right, so the purpose, basically, in a PL SQL subprogram, you can execute, if you execute it correctly, basically you won't run into failures because of something has changed. And generally, you have to remember that objects are objects in your database, and basically, most of the database systems will have functions in place to check, to ensure you're not running into certain types of dependencies. So, yeah. So, where was I? So you can execute correctly only if the objects that it references exist and are valid. So basically, you can only select a table that actually exists, right? If you try to select a table that doesn't exist, then primarily you'll get a warning that that table does not exist as an object. All right. Okay. All right. So these objects can be tables, views, etc. All of your objects, procedures, subprograms, everything. So what happens if a reference object is altered or dropped? It really depends. I mean, that's where dependencies come into play. If for some reason you inadvertently drop a table or drop a program, or even change a package, a subprogram that's a part of a package. I mean, this is all about dependencies. I mean, and basically when you want to execute them, then it will give you the dependency errors. So this lesson introduces you to object dependencies and implicit and explicit recompilation of invalid objects. And all that means is that basically you'll get those dependency errors, and essentially you as the programmer will go back in and ensure that that object is either named correctly or the syntax is correctly, or the table, the row, the column is, hasn't changed or hasn't been altered, things like that. Okay, so understanding dependencies. Some objects reference other objects, so that's a dependency. We've established that. For example, if you have a store procedure, or a store procedure could contain a select statement, and the select columns from a table. And if for some reason those columns change, then obviously your store procedure will fail. And so this is just another way of making sure that you understand the relationship between what's ran in the procedure and actually how the data are structured. Okay, so dependency issues are pretty straightforward. Basically, if a table is altered, if any object is altered, you have to be very careful. In the programming world, there's a essentially, as far as pre-compilation, there's a check in most compilers that will ensure that the objects exist. In PL/SQL, we do have functions that will run pre-compilation, but generally, especially at this level, it's up to the user to figure out if there's truly a dependency error or if the object has been essentially altered. Oracle, the newer versions of Oracle will give you a pre-warning about dependencies, so you don't actually, it'll roll back the functions or the block code before it runs because it has discovered a dependency issue. Now, in most cases, that dependency issue, you can investigate that. Most cases, it's generic. And in our case, you can read the object or view the object that's creating the failure, and just recognize that there's either a syntax or it's been altered, or you just have to change the code or recompile or something like that. So, however, to manage dependencies, all schema objects have status. Yeah, they're in Oracle. Well, in most DBMSs, all the objects are recording a valid or invalid status, so that whole pre-compilation phase will recognize before any parts of the program are ran. And as you know, there is that user objects table. You can always view essentially any of the objects that's a part of your user session, just to check to make sure that the objects exist. That's always the best approach to eliminate dependency issues. The graphic in the lecture, I mean, it seems pretty complex, but it's just basically illustrating the direct dependencies. You have a direct dependency between a procedure and a view and a table. I mean, it's named correctly. So if anything happens to these objects, if they're altered, if they're dropped, et cetera. Then obviously the direct, the valid, invalid, essentially reporting scenario will notify essentially, well, it doesn't really notify, but it'll be listed in those objects tables, recording tables, that there's a problem with the dependency, with the direct dependency. So dependencies essentially can be summarized in two types of objects. You have your dependent object and your reference object. Obviously, tables, views, triggers, procedures, functions, package body, package specification, and user-defined object or collection types are dependent object, which means that these objects will be referenced by something else, and they have to be, they will report a valid or invalid status before the programs or subprograms can be ran. And compare that to the referenced objects or objects that are referenced, functions, package specifications, and you see that package specifications are in both places because the package specification is essentially how you define the package body. And generally, if there's a problem with the package specification, as you all discovered, I mean, you have to either recompile, rebuild, et cetera, et cetera. Procedure sequence, that's the sequence within procedures. Synonyms, tables, view. And you see that there's essentially cross identification as far as the objects. And it seems like they can be listed as dependents or reference, and that's true. I mean, it's that type of scenario. And it really depends on the specific scenario, whether you're calling or executing a subprogram in a package or running a procedure. Remember, a procedure basically depends upon either another procedure or another object for it to be successfully ran, I should say, not compiled. Okay, so there are such things as local dependencies. In the case of local dependency, the objects are in the same node, and that just means essentially, well, let's see, I want to make sure, because there's always confusion about direct dependencies and local dependencies. And for our database scenario, essentially all of our schema and our objects are under the same node. If we were crossing different database schemas and scenarios outside of our little DBMS, then you would have, well, we can call them global dependencies, but that's a little bit different. That invokes a little bit more complexity. But for the most part, we're looking at local dependencies because everything that we're running in our little instance, and this instance is a control instance because it's a cloud base, and we're all essentially hitting our own portion of it. So as to not complicate this too much, we are generally dealing with local dependencies in our little environment. So, and the Oracle server, especially this cloud version, is managing your local dependencies. Hence, if you create a table or drop a table, basically the Oracle server system will recognize that particular object and that's where the valid, invalid status comes from. And it's interesting now because in the Oracle and in some of the other DBMSs, SQL Server, et cetera, whenever you run a DDL statement, it produces a specific status as far as dependencies, because generally you are affecting the database structure. So, and that whole idea that this particular, let's say a table, there's a relationship table to table. If for some reason that relationship is broken or changes some, then the whole dependencies scenario will change accordingly. So it's good and bad as long as well, depending on what your role is. If you're an analyst and you're not dealing with the structure of the database, then it's not too big of a deal. But If you are the database administrator, then you're depending upon those dependency tables and the dependency statuses to ensure that you're not causing an issue with dependencies. And it can be a problem. Um, and this is one of the reasons why database administrators are constantly reviewing the status of those, well, just everything, the object tables, the dependency tables, etc. All right, so just to attempt to illustrate the difference, local dependencies are like, you have procedure A, procedure B, and your view in your table, and and it's just essentially stating that there's a dependency between all of these objects. If any of these objects change within the node, then basically you have to address that issue. And for our purposes, once again, I'll reiterate this, as far as local dependencies and direct dependency, there's really no need to consider those different. I know when we talk about variables, we have local variables. Is it in the subprogram? Is it in the declaration? Think of this as a little bit different than that scenario, because we're not using complex database schemas or anything like that. We're using basically our own little Oracle schema. So our dependencies are all local. Any questions about that? You're all so quiet. We're all still alive out there.
Yeah, I feel like some of this stuff is a little over my head. I mean, I've read it, try to understand it, but.
Well, it shouldn't be, well, I don't know if it's over your head. The way it's structured on the database side, that's probably a little bit more complex than you, but then you need to know. But as far as understanding that there is a well, you understand that there's a dependency between when you build a procedure and you're running a procedure to do a certain thing that affects a certain object. You're just establishing that this dependency between the procedure or the subprogram and the object. And the procedure is an object and the table is an object, but you're creating a dependency, meaning that if something happens to either of those objects, then obviously either there must be a modification, or you need to perform something to ensure that the dependencies have been redone or revalidated. And speaking of that, generally, and all this slide is illustrating is basically if there's a change, if there's some type of change, and that's usually some type of DDL change, structural change, then your dependency becomes invalid. So if you look at this, if for some reason, I think here we're illustrating that, well, let's say the table change. Let's say there's additional column. The database administrator decided to add a column or create some type of normalization where they're splitting up. And I just saw this today in a database table, demographic table. It consisted of an address field, just address, which had first address line 1, address line 2, city, state, and zip. And so the DBA decided to split that up into separate columns because he was creating a second normal. It's a normalization tactic. And so instead of having just an address field, it had address line 1, address line 2, city, state, zip. So if you had a procedure that was focused on that address field specifically to perform some type of function, well, obviously that dependency is broken because that table has now changed. So, and basically what will happen in Oracle, you get an invalid dependency, and either you modify and recompile the procedure, or force the DBA to change the table back, which they generally won't do.
I got a quick question. The term recompile, is that another word of saying refresh, or was that completely different?
It's a combination. Remember, the compilation stage is something that you have to it's a check and balance. Essentially, let's check this procedure, make sure syntax, functional requirements are all there, and then it actually compiles and completes the scenario to create an object of that subprogram. So it's not necessarily a refresh. Generally, in a recompile, there's modifications, and then the program or subprogram is recompiled or ran through the compiler again. Remember, you only
So
need to, go ahead.
okay, I was just gonna just ask you, just kind of in that scenario. So let's say you do have a, you know, that you have coding ready to go, but it has a dependency on another table. If that other table, let's say an additional row or entry was added, obviously based on what you've explained so far, is that obviously the you know, it might not work because there was the expectation saying, let's say the other table had only this set of data.
Right.
Then is there any way this PL SQL, is there any way of automatically kind of updating because of this dependency on the other table, that if the other table changes, it would also change here, or is that,
No,
or is that?
you can build something like that in, and we'll talk about that, but it's not anything automatic. Generally, even from a database administrator level, if you have that type of dependency where it's column or tuple column based, then generally you want to maintain manual control of that. If you start automating that side of it, then yeah, you can run into issues, no matter how smart your automation is. So that's another one of the returns of the checks and balances of the database integrity. And that's why when you have something that changes, like like a column, like a structure of a record or whatever, then basically what happens is that the DBA will receive this invalid dependency notification, and they will go back in and either have a programmer recompile their code, or so it's one of those. It is one of those checks and balances of the programming side. I mean, you can only automate so much, but with my recommendation with data, you have to be very careful. There has to be a check in there before things are recompiled. And what you can set it up so that basically if there's and that's what's known as a high level change of an object like that, then it will create recommendations, but for the most part, and it's just running a query anyway. But you have to remember, just running a query doesn't necessarily reorganize the data. That's more programming, et cetera. And you can do that. I should answer the question more comprehensively. It can be done, but that's much more coding. And it's really beyond what we would want to do as a scope of this class.
Got it. Okay, thank you.
So in the similar line, like let's say I have created a view based on an employee table, which says that select everything from employee table. Mm-hmm. And then later on, I tried to change employee table and added a couple of columns on it. And then next time I try to call the view, do you think the view fails because it still is calling everything from employee table?
The view will not fail, since you're calling everything. You're doing a select star. The view will still, and that dependency is not broken. I'll show you that later. That is one of the recommendations as far as views. If you're just calling, essentially all of the information from a table. But no, the view will still pass, and the dependency will be persistent in that scenario.
Okay.
All right. So where am I? Yeah, we may run out of time just with the Zoom. Just come back in if we inadvertently, and we'll continue from there. And just following through what Daniel was asking, this is another one of those scenarios. We have a view where we're calling, well, in this view, we're calling specific columns of a table. And remember, a view is essentially something that's designed specifically for a purpose. So you see that in the first scenario, the employees table, the employee table itself is employee ID, last name, first name, email, phone number. And then the view, however we're building a view, is employee ID, last name, first name, email, and department ID. And we're probably using some type of join in our view to create it. But this is the dependency I would be assuming, because we're looking at an add employee procedure, which is tied to this employee view, and then there's a query employee procedure, which is just tied to the employees table. All this is showcasing is that, yeah, this is producing something different, but this does not mean that there's a dependency issue. It just means that that view is different than the actual table. So you can display direct dependencies. Yeah, there's a function, subprogram in there, user dependencies. It's a table where I will actually show you what's valid and invalid. So if you run this select query, I still think it will. I think that table is still in our Oracle. It will show you essentially if you had these two views here. Let's say you built, well, if you had this view here in the employees table, and if you ran the query based on that, it will show you that dependency is valid. It will show you the status of that dependency. Now, remember that this is showcasing an employee view that you may or may not have in your Oracle schema. So I would, if you want to run this user dependencies, make sure you run it on tables that you know are in, or views. You do have views in there as well, views that are in your database. And basically this will give you a status of your dependencies. It's using that user, or looking at that user dependency table. And then you're referencing those particular objects, an employees table and an employee view. And basically this is showing you that the script creates 4 objects. Table, department tree, temp tab, which is just a dependency table, and procedure. And basically if there's a procedure that's dependent, it'll show you that as well. And then your whatever your views are as far as department or IDEP tree, it's a little bit, all those are just dependency association, dependency tree and dependency tree. And if you run this, it'll show you those relationships as far as, actually, excuse me, dependency tree is direct dependency, IDEP tree is indirect dependencies. And indirect dependencies could be a result of joins or any other programs that are running a nested program. there's also, it creates an indirect dependency that will be also displayed in this particular script or select command. And there is a dependent tree function. So once, as with any other function, you can run this in a subprogram, in a anonymous block. And this is just showing you essentially table Scott employees. Those are objects in that in the employees table. And basically you can run a direct or independent view or display in there. Remember, I'm not saying view as in table, but view as in displaying the results of the dependency. Oops. So displaying dependency data using the dependency tree view. And remember, these are just, they're like views or like temp tables. Basically, it will look like the results there on the bottom. basically the table, it'll tell you the type of object and whether it's nested. And essentially it'll give you an idea what the dependency is. It'll tell you that that employees is a table, it's not nested. This imp VW is a view, that's a procedure, that's a procedure. And see, this is a nested, somewhere that's a nested. And basically I'm just showcasing how this would be listed in a result table if you had these particular objects in your database. And this is just showcasing another scenario of local dependency. If you remember that reduced salary procedure and the raised salary procedure, and then essentially how those are dependent or tied to or connected to the employees table, and basically job ID, salary. So it's just showcasing to you the dependency of those procedures to the employees table. Third scenario of local naming dependencies. Basically, this query employee table is just or procedure, excuse me, is tied to the employees table, but the employees public synonym. It says it's basically showcasing that it's not dependent upon that table, even though it's the same table. It really depends on what that scenario is. Just think of this as that procedure is tied to the employee, is dependent upon the employees table. The public synonym that could be produced by a different scenario. We didn't really talk about synonyms, but essentially that's kind of a DBA level association of the employees table. And it doesn't necessarily mean there's not a dependency. It's just that may be something else within your database schema. But remember that essentially if you have a dependency on something like the employees table, then it would be truly a direct dependency on the table. All right, so recompiling. Basically, recompilation is usually handled whenever you if you alter procedure and then execute, that's essentially a recompilation. But if you read through this, you can handle essentially, and it's essentially, if you're working on dependency, you can handle it through implicit at runtime, which is a recompilation, you just alter and run it, or you can handle it through explicit, which means you actually run the alter and whatever it's, and this is just give you a general idea of what it's named, and then that's essentially just an explicit recompilation. Recompilation. I'll get that pronouncement right. And I'll just think of this as when you change a procedure, you usually just explicitly change it, and then you recompile it. All right, so our lecture will end here in a second. Please just come back in. I will restart it, and we will continue to the end.